In this presentations, I am going to talk about one type of system software, so-called operating system. The basic objective of my presentations will be to discuss the basic points of operating system, what is operating system, how it is different from the remaining system software, what are different types of the system software, and then finally I am going to talk about, as in the previous session, how operating system is going to be designed in the future. So the points which I am going to discuss about is that is called different type of operating system, and I will try to trace its history. It has started with a batch operating system, switched over to the multi-program operating system, network operating systems, and distributed operating system. But first, what is operating system? Operating system is a system software which controls the resources of a computer. You know that we have a different type of resources in the computer. Although we say that the computer contains two major components, hardware and software, but it contains many other components which belongs to hardware and the software. So we have within the computer you will find that we have one device is called memory device, another device is called processor, the third is called I/O, and the fourth is called the file system. So the objective of operating system is to control all these resources. When you interact with the system, operating system when you try to interact with computers, operating system is sitting between you and the computer. It takes your commands and try to translate it into the machine language, or it calls a different utilities to do its job. So operating system is very important. Operating system has to play a very important role in the functioning of a computer. It means that if you don't have an operating system with you, your system is not going to work at all. For example, if there is no transmission, your television is going to be dumb. Same way, if there is no operating system with you, then definitely you can't do anything with your system. So we have different type of operating system. For example, we have Unix operating system, Windows 95, DOS, VMS, and so on. Right? First, I will try to trace its history, that how everything started. You know, the earlier people used to work with a console, which was a separate device altogether from the main system. But the development of assembler, compiler, interpreter definitely improved a lot. But again, system throughput was very less. Right? So what used to happen is that a programmer used to work as an operator. He used to program as well as load all these assemblers and compilers for running the program. So finally the operator was appointed, and his job was simply to do the setup. For example, if you want to run your program, COBOL compiler, if you want to run a COBOL program, then job of operator was to load COBOL compiler. If you wanted to run Fortran, then job of operator was to run a Fortran compiler, and so on. So the job of operator was to do the batching of similar jobs. For example, so this way batch operating system started. So the basic objective of batch operating system was to batch similar jobs. For example, if you have to run Fortran, COBOL, and Fortran, so that you want to run 3 programs, 2 in Fortran and another in COBOL, then one way to run these programs is to first run the Fortran program and then run COBOL program. Otherwise first you have to set up the COBOL Fortran compiler, then again COBOL compiler, and finally Fortran compiler, and so on. So when we talk of a batch operating system, main task was the control from one task to another task, or let's say one job to another job. A special software was created, so-called monitor, distance monitor. It used to reside into the computer's memory. Its job was to automatically sequence one job from one job to another job. Then you can ask then how distance monitor came to know that this is the end of a job. It was job of a programmer to write a series of control cards to indicate that this is the starting of the first job, or this is the end of the first job. So for example, he used to write this way. just in this case. So what he used to do is that this is the indications that one job is starting and he is going to write a COBOL program. So operator has to load COBOL compiler. Apart from the data and program, a programmer used to load the control card to indicate the start and as well as the end of the job. And it is job of a distant monitor, which I showed you in the previous slide, to switch over the control from one job to another job. Basic bottleneck with such operating system was that it was not very interactive. This number one. And second was that the speed of the CPU was much more faster than the speed of the card reader, which used to be used as an input device. So finally what they did is they developed, during the same time magnetic tape was developed. The job of course magnetic tape was much more faster than the card reader, but again the speed of the CPU was much more faster than even magnetic tape. So finally they developed a new concept called the spooling. Spooling stands for simultaneous peripheral operations online. During the same time hard disk was developed, and the purpose of the hard disk was that at one area you can store one input image, another area you can use a print image, another area you can use some intermediate results. So the hard disk really brought the revolutions. So one can easily switch over from one area to another area, which was impossible with magnetic tape. So now the point was, so once again just let me summarize with the batch operating system, was that first that it was not very interactive, and the second was that it used to work mainly with magnetic type of devices which didn't support card reader and the CPU to work together, because for everything because we can't switch over from one area to another area so fast, because always we had to rewind for all these operations. Now the real thing, then we move to new generation, and that is called multi-program operating system. The basic theory about multi-program operating system is very simple. At a time you can have many programs into computer's memory, which I showed you in the previous slides, right? Although it is basically related to the batch operating system here, but you can see that at a time you can have many programs into the computer's memory instead of having one program, which we used to have with the batch operating system. So if CPU is through with one program, it can switch over to another program. So, or if the program one wants some input from the user, then CPU will switch over to another type of program, right? So this way the efficiency of the CPU increase much more faster. In normal case, when suppose let's say I want to run two programs, only one program will be residing at a time into the computer's memory when you are running one job or one task of it, and when it is right, so when it wants certain input output, CPU is just sitting idle. So then after you have fulfilled its requirement, then again it start with that one. When moment it requires some more input or let's say some output, CPU is sitting idle. So it means that we are not able to utilize its time effectively. But when you work with multi-programming operating system, the moment system is through or P1 requires some input, then it will switch over to P2. Moment P2 requires some input, it will switch over to P1 and so on. So switching of control from one task to another task was very fast here. That is why utilizations of the CPU was much more than the previous operating system. So let's move to more detailed discussions about multi-program operating system, and these are multitasking, time sharing, multi-process and real-time operating system. They are different form of multi-programming, right? So when we talk of that there are multiple programs residing into the computer's memory, it does not mean that many CPU is only one. Only in different, what CPU does is in different slices, it gives a different time slice to each controls, to each job. Moment one is through with this one, one is switching over to the next job. So what is the purpose of the multitasking operating system? Multitasking operating system refers to simultaneous running of several processes. Suppose that you want to do database processing. Same time you want to do certain calculations, you can switch over to another program. After doing the calculation, again you are back with the previous program. So then what is multitasking here? That system is doing two different tasks, although at two different time cycles. So when you switched over to another task, so-called calculations, the CPU didn't swap the previous task to the hard disk. It kept those things into the main memory itself. So the point is, sometimes you will see that certain processes are being run behind, so-called background processing, and something which you are seeing running on the front, so-called foreground processing. So system runs many processes simultaneously, although it has got only one CPU with it. Now let's move to the another type of operating system, multi-programmed operating system. Time sharing. The basic objective of time sharing operating system is to give you the interactive environment, right? You could interact with your system. Take example of railway reservation system. It's basically time sharing system. Multiple terminals are hooked to the same system, and every user thinks that system is responding to his terminal only. But system is switching so fast that you will not able to realize that there is only one CPU or there is only one main system sitting here. Right? So the basic purpose was to provide an interactive environment which you didn't have in the batch operating systems, and it was much easier to do the programming in time saving system, because development, the debugging was also much easier here. Then we have a multiprocessing. Multiprocessing operating system is it refers to more than one CPU. When you have multiple CPUs working for your problem, then it is called multiprocess operating system. Definitely, then work will be much more faster, because same problem is being worked by many other CPUs. So if you want to do more complex operations, for example, if let's say have a weather forecasting and so on, then definitely you require much more faster calculation, and more than one CPU might be its solution. And then we move to another form of multi-programmed operating system, so-called real-time. The basic objective of real-time operating system is to provide a quick response time. Right? This real application is in the industrial control system, for example, nuclear plant or the chemical plant. So every action has to be done within a stipulated time period. So the real-time operating system is basically used for those type of applications now. So this way we have finished the different forms of multi-programmed operating system. Now let's move to another type of operating system which is emerging today, so-called network operating system. Network operating system is not very much different from the main operating system which you have seen, Unix or let's say DOS, right? Its basic purpose is to control the networking environment. So the most of the functionality are similar to it, similar to any operating system. But the real difference between the network operating system is that they provide you they support the networking environment. Today we are passing through networking era, right? So your system will be connected with the many other computers. The real advantage of a networking operating system is to have resource sharing. Suppose that you are attached to site A, and you don't have access to printer, but site B has access to a printer. In networking environment, you can easily do your printing job, although you don't have access to all the system. So the job of operating system is, apart from doing the main functions, it also controls the networking environment. If you have only one printer, but lots of people want to print, so the job of network operating system will be to form a printer queues, so that who has given the command for printing will be printed first, and so on. And also in network operating system, the real danger is because your software might be accessed by many others, so security is the main problem. So one of the main objective of network operating system is to provide security to your operating system. So this way the network operating system is different from the normal operating system. All the operating system which you see are basically, network operating is basically extension of what you have. Today you have worked with novel netware. It's basically they support their own operating system, but the basic functionality is similar to DOS or Unix operating system. Okay, so when you want to select, right, the network operating system, definitely these are the things one has to consider, right, that you have a fault tolerance, ease of administration, because your operating system will be little bit much more complex than the normal operating system, right. So how easy it is to manage the system, okay, what a type of platform is required to support this type of operating system, how it is easy to control, how it is easy to be used by your clients, how much memory do you require. So these are important things I have just listed when you want to purchase a network operating system, for example, novel network. So these are the important criteria, memory or the platform, or let's say how it is easy to control that administrations and so on. These are the important criteria one has to consider, right. Now let's move to another type of operating system which I have listed in the beginning, so-called distributed operating system, right. So the distributed operating system is again very similar to network operating system, but the difference is in you have to do lots of administrations yourself in network operating system, whereas in distributed operating system most of the things can be done by the operating system itself. So it is little bit much more complex than the network operating system. The real objective of distributed operating system is to support distributed computations. For example, suppose that you are working with a complex operations, right. If you are working with complex operation and your CPU is not sufficient enough to handle that type of situations, not very capable, they not have powerful CPU, then if you are working with a distributed operating system, then your operating system will transfer that operations to, or let's say engage many other CPUs to work on your problem, so that you can achieve your result faster. So the real, in fact, today's trend is for distributed computations. You distribute the job among several CPUs, right. Another advantage of distributed operating system is that you have if you want to increase its power, let's say I want to increase 15% capacity, you simply add 15% of the processor's capability, right. So you can easily increase the capacity or decrease, or let's say for example, if certain machine is down, right. If certain machine is down, it does not mean that rest of the system will be down. Rest of the system, you can work with the rest of the system, so it provides you much more reliability. And another interesting fact which is very common between network operating system and distributed operating system is that sharing of the resources. You can share the resources there as well as here, right. So both things are common, but what you have here is distributed computation. It means that you engage much more CPUs, many more CPUs to do your task. Now after that, this one I will move to in fact this is my last objective of my presentations, is that where the future operating system, I mean where the software is, how the operating system is being designed in the future. That is right. So first thing is that in fact you must have guessed with our presentation that the multiprocessing is the one area where your operating system has to concentrate on, because the CPU cost of the CPU is declining, right. Cost of the hardware is declining. So instead of having one CPU, you can have more than one CPU in your system, and you can do much more complex job. Then you can write, then operating system has to be rewritten, right. Not only that you have to write only the application software entirely different way, but always you have to, operating system has to support more than one CPU, because The reason being is that you have to schedule the job not among the one CPU but among the multiple CPUs. So the one trend where the operating system is going to be designed in the near future is that it is going to have more than one CPU with it. The second is that faster executions through microcode. Right? It means that very soon you will find that your system software like operating system will be bundled into the hardware. The real advantage of putting something into the hardware directly is that access time will be much more faster. It means that the future operating system will be much more faster because they will come into the chips, right? The third is already I have told you is that hardware cost is coming down. We are moving to the networking environment. We are moving to the communications age, right? We want to share our informations with others. Then operating system of the future is going to support both distributed operating system as well as network operating system. Another important point is that the future operating system is that they support the concurrency. What do you mean by concurrency? By concurrency means that concurrent executions of processes. I have already explained you what do you mean by process. Process, when you start, for suppose that you have written a program, when you start running your program, it becomes a process. What does it mean? It means that memory is allocated, some registers will be allocated, control will be given to it. So it becomes a process now. It will able to do many more processes, many more tasks simultaneously, right? For example, just try to understand this concept because that is a very important concept. For example, I can say that the batch operating system is a collection of three processes: the read process, executions process, and print process. Okay, so whatever your card reader is doing is basically creating a reading process. Whatever CPU is doing is basically doing the executions, and whatever printer is doing is related to the printing process, while CPU is doing so here with same CPU we are doing three processes simultaneously. While CPU is working with a particular process, particular task, at the same time card reader is going to read the next job, and at the same time might have that printer will be printing the contents of the previous job. So three processes by overlapping input-output processes can do three jobs simultaneously, and that is why, I mean, this is the real advantage of the spooling concept, simultaneous peripheral operations. Online many operations can be done, and hard disk is of much use here. So anyway, the point is here once again, the concurrency is that many tasks can be done simultaneously. Then you have definitely for that you have to write a new operating system. You must have a new type of language. Today we have a concurrent programming language, right? Concurrent object-oriented programming language. So real advantage of the concurrent object-oriented programming or the concurrent language is that user can create a parallelism in its program development. And finally, one more point is maintainable and reliable. Today's software is being designed based on software engineering principles. Okay, software engineering is a discipline which basically tells that how to develop or design a software in more reliable fashions. It means that tomorrow's software will be much more reliable. You can easily maintain your software. You can easily design your software. You can easily debug your software. Even object-oriented programming is in the same direction. So, because software is a very complex software. So, the one problem one faces with complex software is how to maintain them. Once you develop, if certain things you have to add to it, how easily you can do it. So most of the software operating system today supports software engineering principle, and then it will be much more reliable and maintainable. And another important point which I want to explain is here is that the future operating system is going to support multimedia. Today they mainly deal with textual type of informations, but you will find very soon that they are going to support not only one type of data but multiple data types. audio, sound, video, animations, graphics, then definitely the applications development in that type of programming environment will be much more exciting and so on. So this way, let me summarize very quickly that I discussed with operating system software. First I discussed the basic of system software. First I discussed with the basic of operating system, different type of operating system, batch operating system, different forms of multi-program operating system, and finally I gave you some glimpses of how operating system is being designed in the future. And these are, once again, they are going to support more than one CPU. They are going to have support more than one different type of data, for example audio, video, animations, graphics. They will be much more reliable and maintainable, right? They are going to support networking and distributed type of operating system and so on. This way we want to bind up, and thank you for being with us.